what is the magnitude of the following vector? So your vector is going to be written like this. It's going to look in a way that maybe you are not familiar with. So we've got the force vector, or F vector. It doesn't have to be a force. Just in any case, it's a vector called F, equals A1 I hat. That's what this little thing is. It's a lowercase letter I with the hat on top of it, plus A2 J hat. Okay, so what did the I hat and J hat mean? I hat you can also think of as X hat. That means that that's the component of your vector in the X direction. Okay, J hat you can think of as Y hat. Okay, and Y hat, that's the component of our vector in the Y direction, okay? So it's a little bit different sometimes depending on your textbook, whether they will use I hat, J hat, and K hat to represent the X, Y, and then the Z component, okay? So if you see I hat, it means X hat, it means X component of your vector. J hat means Y hat, that's the Y component of your vector. In this class, we're not going to worry about the Z component, which is our third dimension. We're only going to operate in 2 dimensions, okay? So A1 and A2, those are quantities that tell us the size of our X component and Y component. So for me, I was given A1 equals minus 3.3, and A2 is equal to minus 13.7. So if I rewrite my vector using those components, my vector will look like this. F is equal to minus 3.3 I hat minus 13.7 J hat. Okay, and then we want to find the magnitude of that. So the magnitude of our vector is going to be equal to the square root of the X component of that vector squared plus the Y component of that vector squared. Okay, so that's going to be equal to the square root of minus 3.3, all of that squared, plus minus 13.7, all of that squared. And then that is equal to 14.1. There's no units on this problem here, okay? So the magnitude, the size of my vector is 14.1, okay? Now, be careful when you're putting these quantities into your calculator. You have to put a parentheses around the whole minus 3.3 thing before you take the square of it, okay? Same thing with the 13.7. You put a parentheses around the minus 13.7, then you take the square of it so that these terms become positive. When you take the square of a negative number, that becomes a positive number, and then you can take the square root of that without having any imaginary numbers, any problems with your calculator, okay? So what does this, this is not part of the problem that you have to solve, but I want to talk about what does this vector look like when if we were to draw it. And we are going to draw it just so you can make the connection between what you see here and what it looks like in space. So let's say we've got our coordinate system here. Okay, this is the y hat coordinate system. Okay, y hat direction, and here's my x hat direction. Okay, now my vector has a component minus 3.3 in the x direction. So that means it's in the negative x direction 3.3 units. So I have to go over, let's say that this is 3.3 units. I had to go in the negative direction. And then I have to go down 13.7. That's the negative part on there. It tells me I have to go down, okay, here. Negative 13.7, okay? So my vector would start with the tail here and end with my head of the arrow right here, okay? So for my vector, from starting here, I have to go over 3.3 in the negative x direction and down 13.7 in the y direction to get to my spot. So this is what our vector f looks like in three-dimensional space, okay? And then it will have a size of 14.1 if you were to go ahead and measure it, okay? I know that this drawing is not to scale. All right, now let us do a similar problem, but instead of finding the magnitude of our vector, we are going to find the angle the vector makes with the positive x direction. Okay, so angle, that's kind of what this little symbol represents. This is angle of f with respect to, that's what WRT means, with respect to positive x-axis, okay, in degrees. So you're going to be given a whole new vector with a whole new set of numbers. It's going to be given to you in this kind of same format here. And so for this problem, let's say that I have a vector f, okay, that has a component a1, that's my x hat component, of 3.2. So I'll write it as 3.2 I hat, which remember is also x hat. And then it has a value for a2, that's my x component of my vector. I'm given a value of -2 for that. So -2 j hat, which remember is also y hat. Okay, so that's my vector here. And I want the angle that this makes with the positive x-axis in degrees. Now I'm going to draw what this vector looks like, because anytime I'm asked for an angle, I need to understand where that vector is in space, okay? Where is it lying with respect to the positive x-axis? Now I'm going to draw this vector. Now your vector is going to look different from my vector, okay? But you're going to use similar methodology here, like the way I'm going to walk through it, okay? So here again, I'm going to draw my coordinate system. Here's my y hat axis. Here's my x hat axis. Oops, this is x, right? Y hat, okay. So this vector here, oh, sorry, that's kind of off the page, isn't it? Plus x hat. The pink doesn't show up as well. Okay, so this vector, and to draw this vector, I have to go 3.2 units in the positive x direction. So let's say that's this right here, 3.2 in the positive x. And I have to go 2 units in the negative y direction. That's what that -2 here means. So I'm going to go down 2 units here. That's -2, okay? So then my vector, if I draw it, starting from the origin and ending here, okay, this is my vector f. So I have to go over 3.2 in the x direction and down 2 in the y direction. And here is the angle theta that I'm being asked to, well, this is an angle that we will call theta, okay? This angle theta that we find is going to be this small angle right in here, okay? So the directions of the problem ask you to find the angle of your vector with respect to the positive x-axis in degrees, okay? And it also asks you for, to report this number as a positive number, okay? Report positive value, all right? So we want the positive angle of this vector with respect to the positive x-axis. So that means I start at the positive x-axis and I go around for my angles. The convention is to make positive angle be counterclockwise here, okay? So this whole angle that I just drew, starting from here, going all the way around and ending right here, this is the angle that you are going to report in the quiz. Okay, so it's going to be bigger than 180 degrees. It's going to be a large angle, but it's not going to be quite 360 because 360 would be going all the way around. So in order to report our angle with respect to the positive x-axis in degrees, we want the positive value of that angle. What we can do is we can find what this little angle is in here and subtract it from 360. And so what you're going to find is you're going to figure out what this angle theta here is. You're going to take 360 minus that angle, and that is what you're going to report in Canvas, because that's this angle that we're talking about right here. Okay, so let's work on how we get that angle. So we can use trigonometry. We know this leg and this leg of the triangle. This is my angle theta, and this right here is a right angle, so this is a right angle triangle. Then my vector here is the hypotenuse of that triangle. So we can use tangent theta. Tangent theta is equal to opposite over adjacent. So tangent of theta is going to equal to, here, I'm going to use the positive value of my opposite side, okay? So I'm going to use 2 over adjacent side is 3.2. So this is the adjacent side to my angle. And so in order to get rid of, to get theta isolated, I have to take the inverse tangent of both sides. So theta is going to be equal to the inverse tangent of 2 over 3.2. Be sure you're in degree mode. And this is going to give me, in my calculator, inverse tangent of 2 divided by 3.2. That's going to be 32 degrees. Okay? Now, if I were going to report my angle with respect to the positive x-axis, I could say that this angle is negative 32 degrees, okay? Because I have to go 32 degrees clockwise, which has the convention of having a negative sign for the angle with respect to positive x-axis. Or, since the instructions are telling us to report the positive value for this angle, what I have to do is take 360 minus 32. And so 360 minus 32 gives me 328 degrees. And so this is the angle that I would report for this question in Canvas. This is my angle of my vector with respect to the positive x-axis in degrees, and I'm reporting the positive value for that angle. Okay?